Alright, so in this video we're going to create some geometry that basically, if you look at the bottom part of this drawing, we're looking at the side view of a thickness profile of a core. And so what we're going to do is create this geometry in Bobcad in such a way that we can generate some G-code to cut it on the CNC router. So we're essentially going to make a 3D surface and then tell the router how to cut it out. So what we would want to do first is go File, New, and select Drawing, and that just opens a blank drawing with 0, 0 axis right here. I'm actually going to, 0, 0 right here. And so what we want to do is we're going to basically draw a rectangular core that goes like this, assuming this bottom left corner is the left-hand rear corner of the CNC router, and we're going to place a core blank on it, and then we want to mill it out so it has the variable thickness going back and forth like the mouse is doing here. So the first thing we want to do is create a line, and then we want to make a copy of that line, loft a surface between it, and that'll give us the three-dimensional data we need in order to mill the surface. So what we're going to do is start with the first point being at the tail of the core here and move all the way up to the nose and basically mimic this top profile, the profile line. So at this one we're going to open up a command called line coordinates that basically is the start and end coordinates of a line. And the first coordinate is going to be at 0, 0, and if you look at the drawing at the back here, it's 2.5 millimeters high in Z space, so we're going to put 2.5 there. And then if you look at the next one, it's going to be 158.4 this direction, which is actually going this way on the in the drawing, or on the in the drawing we're making, and it needs to be 158.4 millimeters from there, and it's still 2.5. So we want to type in this blank 158.4 and in this blank 2.5. And then you hit continue. Not OK. You want to hit continue because you want to continue this line and keep doing the same thing to make a long line. So we go continue. Now what we want to do is move the end coordinates over to the start coordinates, because they're going to be the start coordinates of the next segment in our line, which is 158.4, 0.4 and 2.5. And then the end coordinates are going to be another 264.3 millimeters this way, and we need a calculator to figure out what the total is. So we want to go 158.4 plus 264.3 equals, and the next point is going to be 422.7. That's right here would be 422.7, and it's going to be 7 millimeters high. So I'm going to go 422.7 and 7 millimeters, and then we hit continue again, and then we'll draw another segment. So we want to put the 422.7 in this blank. We want to put 7, so we've got our starting point. And then here, we want to add another 333.8 millimeters, and it's going to be 6 millimeters high at that point because it tapers down a little bit in the middle. So we want to go plus 333.8 equals 756.5. So our end point is 756.5, and it needs to be 6 in this blank, and then we hit continue, and then we translate those numbers over. 0.5 and 6 millimeters high, and then we need to add another 333.8 to this. 333.8 equals 1090.3. So our end point is 1090.3, and it's going to be 7 millimeters. If you look at the drawing, 7 millimeters there. Continue, and then we translate this number 1090.3 and 7. And then for our end coordinates, we need to add 264.3 this time. So plus 264.3 equals 1354.6, 1354.6 millimeters. And that is 2.5 now, because we're actually at this point on the core. So 2.5. Hit continue one more time. And then 1354.6 and 2.5. Now the end coordinate on this drawing at least is another 158.4 forward, so we want to add 158.4 here, and the end of this core is 1513, or in this case it shows 1512.9, but we're probably just have a rounding error going somewhere here. So plus 1513 in this blank, 1513. and it stays 2.5. And this time we can hit OK because that line's actually finished. Now, if I click up here in the blue, just to make sure I've selected this, and then I hit the Z key on my keyboard, it'll zoom out to the whole line. You can see the line goes. And if you go View, select 3D View, we're looking in the top view right now. We're going to change to the side right view, and then hit the Z key again so it centers it up. You can see how the line starts up and it sort of tapers up a little thicker, dips down, and goes up a little thicker. Now, of course, it draws kind of a jaggly line because we're looking at it on a really low resolution in a computer monitor, but it's actually a super high resolution line that goes for this variable thickness, and that's exactly what we're going to be cutting the thickness taper on the router. I'm going to go back to the top view, select View, Top, and then I'm going to hit the Z key one more time to zoom out to it. Now, one thing I tend to like to do on cores is add a little bit of length on the ends, just so that when you're cutting them out, you don't accidentally miss the shape just by a few millimeters if you don't get it perfectly aligned on the router table. So what I'm going to do is I'm going to create a little bit of an extra length at 2.5 millimeters on each end, maybe 20 millimeters or so. So I'm going to go back to my line coordinates, and it'll still have the last one we did here. And I go 1, 5, 1, 3, and 2.5 is the start coordinates. And then I'm going to add 20 millimeters to it, which is 1, 5, 33. At 2.5 and then I'm just going to hit OK, and that's going to draw just a little extra line segment up here. You can see that's what we just drew, is this little line segment up here. And to do the same thing back here, we're going to go line coordinates, and since our first coordinate was at 0, 0, and 2.5, that's easy to remember. And then this time we want to go minus 20 millimeters because we're going 20 millimeters below 0. Like, on this side of this horizontal line is negative numbers because this is the 0 axis. So I'm going to go minus 20 on the Y at the same height and hit OK. And you can see that just drew a little line segment. So that gives an extra 2 centimeters on this end and 2 centimeters on the front end in order to just give us a little bit more room when we put a core blank on the router in order to get it straight. And then I'm going to take this whole line and select it, and I'm going to scooch it forward 20 millimeters just so that this start point is at 0, 0 and not at minus 20 and 0. So I'm going to go Change, Translate. I'm not going to translate it all on the x-axis. I want the scale at 1. I'm going to translate 20 millimeters on the y-axis, nothing on the z, and I'm just going to hit OK. And that just pushes the whole line forward so that this start point here on the line is at 0, 0. If I zoom in here with the V key, you can see the line starts right at 0, 0 and continues on to 153 or whatever centimeters that is. Now I'm going to hit the Z key again, which zooms out to the whole drawing. And so what we want to do now is make a copy of this line and loft a surface between it. Now, typical core blanks are like 320 or 330 millimeters wide. So what you want to do is make a line, an exact duplicate of this line, 320 millimeters to the right, and then we want to loft a surface between it so we've got three-dimensional data that we can generate code from. So what you want to do is take your V key, which gives us the magnifying zoom, and sort of highlight around the axis, and then you want to click the line here. Oops, and if you look here, it's got an arrow going this way, which is the wrong way. So I'm going to do this one more time. I'm going to go Edit, Select, Chain, and then I want to click this, and you can see how when I move my mouse, the arrow changes direction, right? I want to click on this side of the arrow off the drawing again so that the arrow stays going this way and it stays highlighted red. So I'll do that one more time so you can see. You go Edit, Select Entities, Chain, because we want to select this whole chain of lines, and we click here, and now the arrow's facing towards the 0 axis, but if we move the mouse this way, it changes direction, and we want it to go that way when we're selecting the points. So now I click again on the drawing with the left mouse, or sorry, the left mouse button, click, and it stays red, and then I hit F3 key. And if I hit the Z key now, you can see how when I hit here, I'll do this again really quickly so you can see it all light up. I'm going to Edit, Select Entities, Chain, and then I want to select this first line, and then I want to go this way to make the arrow go that way, and then I click again on the white part of the drawing, hit F3, and it selects that whole bunch of geometry continually. In theory, you can just drag it like this, but sometimes you'll get an arrow going the wrong way and it won't work. So it's best to always select a chain in the order, in the direction you want it to do, so that the cut goes along in the direction you want it to go. So I'm going to, one more time, select entities, chain, select that first geometry, get the arrow going the right way, hit the F3 key. Now what we want to do is make a copy of this. And the way you can do that is if you go to change, translate, even though this doesn't say make a copy, there's a copy button in here where it says we can make a copy right here. And we want to translate it on the x-axis, which is going this way, 320 millimeters, because our core blanks are going to be 320 millimeters wide in this case, and then 0 there. So we're going to basically make one copy. So if I click this make a copy at the same scale, one copy, I could go 3, it would make 3 copies of this on, but we only need 1. So put the 1 in this blank. We wanted it in 3 dimensions because we want our z-axis data to read through, and hit OK. And you can see how that made a copy of this line, and everything is still highlighted red, so everything's active and everything's going the right direction, so we don't have to do anything with this geometry to select it in order to loft the surface. To loft a surface out of this, we go to the solids menu here, surface creation, and then we want to go to cross section, which basically takes 2 lines and draws a surface between it. In this case it's showing 9 lines, but we're just doing it with 2 lines, so this doesn't necessarily make sense by looking at it. But we want to choose cross section and hit next. We want to leave convert to spline as linear. We don't need to hit equalize, and we hit OK. And you notice when we do that, it's created a solid surface, and then there's 2 lines here that correspond to where those taper points end, and this is where the binding holes end, and there's actually another one in here, but it's so subtle it doesn't show up as a line, where it's 6 millimeters and this is 7 and stuff in the drawing, and then it's 2.5 in the ends, etc. Now, if we go to the side view here, view, select side, right side again, and we hit the Z key, you can see where I've got it highlighted, it has a 3-dimensional surface. Or if you go to view, there's an isometric view, which is a better way to look at the surface. It's sort of an isometric 3-dimensional view that shows you've got the surface. Now this is not a solid surface, this is just a single surface, but we don't need a solid surface in order to tell the router how to move. We just need to have the 3-dimensional data all along the whole core, so we don't need to do this as a solid. If you've got a different CAD package which has solid modeling, you may do these same sort of steps out of a solid and end up with a solid geometry, but when you go to generate your G-code, you have to just select the top of that solid. In this case, we've just got a flat surface. So I'm going to go back to this view menu, select top, and that'll give us this top view we've been looking at all along, and I'm going to hit the Z key. Now, this is pretty much ready to go in order to to start generating code, but I'm going to at this point save the drawing since we've done all this work, and if the computer crashes we don't want to leave the work. So I'm going to go File, Save As, and we're going to call this SP Twin PA 157 Core Thick. Oops, CKNESS Core Thickness, and it's saved as the format CAD in Bobcad because that's their native CAD format. So save. Now, at least we don't lose this data for some reason the computer crashes, which sometimes they do when you start doing stuff. Okay, the next step we want to do is open a cam menu in the program, which is done by going Special NC Cam, hit Insert NC. It should open up with Mach 3 selected, but if it doesn't, you want to select the Mach 3 Marco post processor, and that gives data that works, that's readable in Mach 3, which is what we use on the CNC multi-cutters, and I hit OK. And that then opens up a NC window here on the right where we can start doing manipulating the data to create the G-code. Now there's a neat little wizard in here called the solid, oh sorry, I got to select the solid first. Select the geometry, so you click on one of the lines so it lights it. You don't want to click on the single lines, we want to select the solid because the single lines are still here. You see I can just select that one part of this line, but it isn't selecting the solid. So if I click here on this line, it selects the whole solid and lights it up red so you know it's selected. Now when we go to the solids menu, it gives us the choice to generate toolpath. If I had nothing selected when I go to the solid menu, generate toolpath is grayed out because there's no solid to generate a toolpath from. So we want to select it. Solid, generate toolpath. Now we want to select the planar, or sorry, a planar toolpath. Here, planar. Next. The router bit that we use for tapering on the machines is either a 1 5/8 or a 1 1/4, and I believe most of the machines ship with a 1 1/4, which is approximately a 31 millimeter diameter bit. It's a flat end bit. It's not a round nose or a bull end. And we want to select the tool tip here for the tool path represent. A step over distance of about 11 millimeters works well, meaning it's going to cut along, move over to the left 11 millimeters, cut back, move over, cut back, and it's going to just 11, 11, 11, 11 across the whole width of the material. In theory, you could do 31, but that results in a bit of a lumpy core where it tapers up and down because of the round diameter of the bit. By doing it at 11, you get a smoother cut, even though it takes a little longer because it's doing more passes. So we're going to select 11. We want to alternate directions. We want a toolpath angle of 90 because we want it to go this way. A toolpath angle of 0 would be going back and forth like this. 90 goes back and forth along the length of the core this way. So 11, 90. You can leave tolerance and minimum line as they are. We want to alternate directions so it goes this way and that way cutting, not just this way, then come all the way back, then this way, then come all the way back, then this way, then come all the way back. There's no holes and stuff to ignore. There's no anything else. So 31. Flat end, tooltip, 11, 90, blah, blah, blah. Hit next. And then it opens the second part of the window where I tend to use useful part and useful part here in these two, or sorry, actually I should do to part edge now that I think about it. Oh, then useful part. So, okay, we're going to go to part edge, useful part here because there are no Z extents, and then this is going to generate all, it's going to compute for a while and generate all the code here that it takes to cut this on the CNC. So I go generate now. And you can see how it drew all these lines on the thing, which is representing the way the things go this way, then this way, then this way, then this way, this many times. All those red lines indicate a single pass on the router. And then it opens up one last menu, which is how you want the router to move towards your first part of the cut, how thick your material is, which is the material top. If we want to enable depth of cut, so we do a certain amount per pass and do multiple passes, which you generally want to do on thick material because it results in a little better cut and things don't explode. If you try and cut all the way through thick material, sometimes the wood splits because there's a grain to it and everything. So in rapid plane, I usually set this at like an inch or so 25 millimeters or so. In this case, the core blanks we have are 9 millimeters thick, so the material top we put as 9. Now, depth of cut, we can probably do this file in 2 passes. And since it's going down to 2.5 millimeters on the end, in theory we're cutting, 6.5 millimeters of thickness to get down to 2.5. So if we did 6.5, it would do this in 1 pass. Now, I think we should do it in probably 2 passes, like I say, just because it's a little easier on the stuff and results in less risk of the wood exploding. So in 2 passes, I'm going to go 3.3, so it's in theory I could do 3.25. Now the feed rate we're going to do is 4,500 millimeters per minute along the length. The plunge is going to be 250 millimeters Z. And then estimate runtime is a thing you can click just to tell how long this program will be run with these parameters we're going to take. So if I click that, you don't have to click that, but when I click this OK button, it's going to take a few seconds, generate all the code, and then it'll give us another box that asks us to put the feed speed so it can tell us what the runtime is. So if I hit OK here. Now, we had 4,500 in that box. So if we type that here, this particular core will take 22 minutes to mill at that feed rate. OK. Now, 4,500 isn't a super fast speed, but on some of the smaller routers we sell, they can't go any faster than that. In theory, I would try starting at a speed like that and just see how everything's cutting. If it looks like it's cutting pretty easily, you can increase the feed rate gradually so you get faster cuts. The other way you can get faster cuts is by doing the step over being more than 11 millimeters, so it's not doing quite as many passes. Or you can even try and cut it in 1 pass, which I generally don't recommend just because there's a bit more risk of the cores chipping and trying to save a little bit of time, but blowing up the core is not generally worth it. So anyways, here's our code that we've generated, but we need to do one extra step here at the beginning if you've got a CNC machine that has automatic spindle control. We've got to add the spindle commands to turn the spindle speed in and to turn the spindle on. Now the command for spindle RPM is S. So if I type a capital S and then 16,000 being the RPM and then enter, that creates a red G-code command of S 16,000 here, the very first thing in the file that's telling the router When we run this file, the very first thing it does is it turns the spindle on, or knows the spindle has to rotate at 16,000 RPM. Now I'm going to hit enter one more time and enter one more line, and that's M3. And what M3 does is it turns the spindle on. So this basically says the spindle is going to run at 16,000 RPM, it's going to turn on, and then it's going to run the file. Okay, now if we go File, Save Copy As, you can name the same thing as SP Twin PA 157 core thickness. Now, in this case, it's not a CAD file, it's the TAP file, so I'm going to delete CAD off the end of it. But it'll still be named the same as this file, but instead of the extension being CAD, it'll come out as .tap, which is the file extension you need for cutting on this in Mach 3. So if I go Save. Now if we go to our menu where we save this, which is File, Save Copy As, it's in the TwinPaw directory. You can see there's one called core thickness.tap, which is the file we just did, and then there's the core template cutting file that we did before that I forgot to put those NC commands in for turning the spindle on and stuff. So I'm going to quickly go in and do that. That's in the public side there, so I'm going to quickly just do that. Go to, where are my Acer users public? Oh no, it's in Studio public. Where did I put these files? It's in It's in EVPC. Okay, sorry. Too many computers on this network. Template cutting file.tap. I'm going to open in Notepad, and then I'm going to add those commands, the S16000 and M3. Enter, and then save. I forgot to do that on the last video, but that shows you how to change the add the extra G-code commands at the beginning of your file. Anyway, that's a quick down and dirty tutorial of how to generate the code in order to load into Mach 3 to cut the thickness of a core.